Assalamu alaikum. I am Rafique Ahmed, Assistant Professor, Department of Physics, Government College, Nawabshah. My dear students, today my lecture belongs to the class B.Sc Part 1, Paper 1, Mechanics. The topic of the lecture is gradient, vector differentiation. Before going towards the gradient, first we define what is the vector operator. The operator used in the vector differentiation is called vector differentiable operator. The vector differentiable operator is indicated by del, and that equals to the partial differentiation with respect to x, the partial differentiation with respect to y, and the partial differentiation with respect to with respect to z. Now, what is the gradient? Let phi x, y, z be differentiable at each point of the space x, y, z, where phi defines a differentiable scalar field. Suppose we have a scalar field which contains three variables x, y, and z. So this field can be written as x, y, z. But there are some changes will take place in this field along the x-axis, along the y-axis, and along the z-axis. So this is the change along the y-axis. This is a partial difference. This is a partial change along the x-axis, partial change along y-axis, and along z-axis. So this field will be known as the gradient of the xyz. So now the gradient of xyz can be written as the phi del, or del into phi. So this is called a gradient. This is called a gradient. Okay. Now the gradient, the del. Now insert the value of the del and then multiply by the scalar field. So the del phi is equal to d over dx I plus d over dy j plus d over dz k into phi, or the del phi is equal to d phi over dx I plus d over dy phi into j plus d phi over d z to k. So this is called the gradient of the scalar field. This is a partial differentiation along the x-axis, along y-axis, and along z-axis. My dear students, and the above expression this term, and this term are known as differentiable derivatives of phi. D phi over dx d phi over dy, d phi over dz, they are known as differentiable derivatives of phi. Okay. So d phi, del phi is equal to d phi over dxi plus d phi over dyj and d phi over dzk. This is called a gradient. Now we solve a problem. Statement of the problem is, if phi xyz is equal to 3x square y minus y cube z square, find gradient at the point 1 minus 1 minus 2. Now solution, as we know, the gradient is equal to d over dxi plus d over dyj plus d over dzk into phi. So the value of phi is given 3x square y minus y cube to z square. Now the d over dxi will be multiplied by 3x square y. So del into phi is equal to d over dx into 3x square y minus y cube z square I plus d over dy 3x square y minus y cube z square plus d over dz bracket 3x square y minus y cube z square. Now we apply the differentiation, we apply the partial differentiation. So d over dx, we only differentiate the x term. So the differentiation of this term will be equal to 3 into 2x y. Now this term does not contain any y component, so it will be 0 into I plus, now both terms contains y, so the partial differentiation will be 3x square minus 3y square z square j and plus, so first term does not contain any y component, so it will be 0. So we only differentiate the second term of this bracket. Minus y cube will be same. The differentiation of z square will equal to 2z. So you can write minus 2y cube and z. So now we rearrange the 6xy plus 3x square minus 3y square z square minus 2y cube and z. Now finally we insert the values which are given 1 minus 2 and minus 1. So here we say the x is equal to 1, y is equal to minus 2 and z is equal to minus 1. So this equation, we put the values of x is equal to 1, y is equal to minus 2 and z is equal to minus 1. So 6, the value of x is equal to 1, the value of y is equal to minus 2 I plus 3, the value of x is equal to 1 square minus 3, the value of y is equal to minus 2 square, the value of z is equal to minus 1 square minus 2, the value of y is equal to minus 2 whole power cube, and the value of z is equal to -1. Okay. So 6 multiplied by -2 will be -12i. Del phi is equal to 6 multiplied by -2 -12i plus 3. 2 multiplied by 2, the 4 plus 4, minus to minus, sorry, -3, -3, this becomes 4, and it is equal to 1. The -2, -8, and -1. So do your numericals, do your calculations very carefully. -12i plus 3 -12, it's the j, and minus to minus plus, plus to minus minus, 2 8 the 16, it's the k. So the -12i minus 9j and minus 6k, 16k, this is the answer of the numerical number 1. Hope you understand the numerical regarding to gradient. Second numerical is to prove that the del f plus g is equal to del f plus del g. So we take left hand side, the del f plus g is equal to this is the operator d over dx I plus d over dy j plus d over dz k multiplied by f plus g. So the d over dx will be multiplied by f plus g I, d over dy will multiply by f plus g, as similarly f plus g will multiply by d over dz. So now we differentiate d f over dx I plus dg over dx I plus df over dy j plus dg over dy j plus df over dz k plus dg over dz k. Now we separate the differentiables which contains the term f and g. So df over dx I plus df over dy j plus df over dz k plus dg over dx I plus dg over dy j plus dg over dz k. From these three terms, the f is common, so the d over dx I plus d over dy j plus d over dz k, f is common. Similarly, g is common from there. So the d over dx I plus d over dy j plus d over dz k, and g is a common. As I told you earlier, this term will be equals to the operator del, that is equals to F, and plus this term will be equals to del, so del and G. So the left hand side is del F plus G. So now del F plus G is equal to del F plus del G. So the left hand side is equal to right hand side. Therefore the given problem has been proved. My dear students of B.Sc Part 1 of Sindh University and Shaykh Mohtarma Benazir Bhutto University, I hope you understand my lecture. Thank you very much.